All right, Algebra B students, this is part 3 of getting ready for chapter 5. This is transforming equations. So, remember, transforming means just to change. We are changing the location of things. We're not really changing the values of everything. We're just going to change the location of things, the variables. So, we want to solve each equation for y. That is our directions for this section, is to solve each equation for y. So our example is 3x plus 4y equals 6. What I always do, if I'm trying to solve something for it, I'm going to go ahead and circle it. Therefore, I know in my mind that is what I need to get by itself, because doesn't solve mean isolate, get by. It means to isolate it. So I really want to remove everything around the y and in order to get y by itself. So what I did was I went ahead and circled y. And remember when we were solving for equations in Algebra A that you had rules to follow? And I always use with my students PEMDAS in reverse. So we know PEMDAS is how we solve a problem if we knew everything, but in this case we don't know everything and we're trying to get something by itself. So in order to do that, I have to go in reverse. Okay, so the things that you need to realize is what is happening to y. What is going on with y? Well, 4 is attached to y, so what operation does that mean? If they're attached, they're hugging, so what can happen if you hug? Yeah, you multiply, correct? So 4 is being multiplied for y. So what I would do is I would put 4 underneath the m. That just, to me, makes me realize, hey, look, I got to get rid of this 4 and what it's doing to y is it's being multiplied. Okay? So what is happening with this 3x? Well, the 3x is positive, isn't it? And isn't positive 3x the exact same thing as saying I am adding? Yeah, it is. If it's something that's positive, I'm increasing my value. So therefore, it's being added. Therefore, 3x is being added to the term with the y in it. All right, so I need to get rid of this. Well, remember, in order to solve for y, we have to go in reverse. So how do I get rid of the 3x? Because 3x is the first thing. If I'm going in reverse, 3x comes up first. How do I get rid of a positive 3x? Well, that comes back down to knowing what inverse operations are. What is an inverse operation? If I'm adding something, what is the inverse operation of addition? Subtraction. Inverse operation of addition is subtraction. So I need to subtract 3 from both sides. In doing so, I can get rid of this 3x on the left-hand side, because what's 3x minus 3x? 0. They cancel each other out, don't they? So what am I left with? I'm left with 4y. And then I'm left with over here, on the right-hand side, 6 minus 3x. Well, going back to up here, what's the next thing I have to get rid of? I have to get rid of the 4, right? What's being multiplied? What is the inverse operation of multiplication? Division. Good. So I need to divide everything by 4. And here's where the mistake is going to be when it comes to a lot of students, and I catch myself doing it as well too. If I have to divide everything by 4, so that's going to cancel each other out, right? So that's going to leave me with y. That's cool. Well, that's going to leave me with negative 3x plus 6 over 4. Is this simplified? It is not. It is not simplified, because in order for an equation to be simplified, there should be no parentheses. And even though when you're sitting up here, there is no parentheses, but there really is. If you look at it as a fraction is grouping, numerators on top, denominators on bottom. You got people on the top floor, you got people on the bottom floor. That is a group. People in the numerator is a group. People on the bottom is a group. So if I look at here, my group in the numerator is negative 3x plus 6. And my denominator is the 4. Well, I can't have that. I got to have individuals. I got to have them split apart, but I want to make sure that the 4 goes to each term. So what I always do, what some of my kids, refer to this as, is the jelly bean or the division rule. Jelly bean are the broken heart, because what they do is they put the 4 with the 3x, the negative 3x, and with the 6. Okay? So then we get down to negative 3x over 4 plus 6 over 4. Therefore, I've distributed. I now no longer have parentheses. Each term in the numerator is over the denominator. But can I simplify something still? Is there something out there that still is not simplified? You can say that, well, negative 3 divided by 4 is negative 0.75. Yeah, I totally agree with you on that. However, I want to leave that as a fraction. I don't want to change that into a decimal. Fractions are so much easier to work with than decimals, because especially when you get into the repeating fraction or repeating decimals, fractions will give you the better answer and the more exact answer. So if I have 6/4, can I reduce that? Yeah, you can. You can reduce that to what? 3 over 2. Good. Okay, so are these similar? Are these the exact same thing? Is y equals 3 over 4x plus 3 over 2 the exact same thing as saying y equals negative 3 over 4x plus 1 1/2? Yeah, they are. Why are they the exact same thing? Well, because 3/2 is the exact same thing as saying 1 1/2. I don't care when it comes to this guy, if it's as an improper fraction or as a mixed number. I do care about this guy. This guy needs to be as an improper fraction, okay? And I'll explain to you guys why later on in this chapter, and you'll understand that much more clearly. Okay, so another example that we have is 3y. 3y minus 2x equals 2. Is that we want to get y by itself. So again, I'm going to circle y. I'm going to circle y because that's what I want to isolate. That's what I want to get by itself. So we know that in order to isolate something, we have to go into reverse PEMDAS. So I've written out PEMDAS, and then I put the reverse sign to remind me that whatever is happening to y, I need to do it in reverse. Correct? Okay, so what is happening to y? Well, we know that 3 is being multiplied to y. And what is happening to this what is happening to this 2x? It is being what? Subtracted. We are subtracting 2x from both sides. Okay, so over here, I have put 3 underneath the m, and subtraction, we are subtracting 2x. Well, according to PEMDAS, and I need to go in reverse, right? I need to get rid of the subtraction part first. So how do I get rid of something that I'm subtracting? How do I undo that? Good, I have to add it. So I can add 2x to both sides. And I come up with 3y equals 2x plus 2 because these 2x's cancel, right? One's negative, one's positive. And then I cannot add 2x plus 2 because they're not like terms. And I always want to put the x value in front. And you'll understand why much later in chapter 8. It goes back to degrees and all that stuff, and we'll talk about that in chapter 8. But I really want you guys to get in the habit of putting the x term first. So we have 3y equals 2x plus 2. Are we done? No, we're not. Why are we not? Because there's still a 3 attached to the y, right? We'll go back to your PEMDAS over here. And you know that you're multiplying by 3. So how do I get rid of something that's being multiplied by 3? Correct, I have to divide. I have to divide by 3 because the inverse operation of multiplication is division. So in order to do that, I come up with y equals 2/3 x plus 2/3. All I did was take the 3 to each term. Pretty much what I did was I skipped this step up here. Because isn't this the same thing as this? I'm just distributing. I just went ahead and distributed the 3 to the 2x and the 3 to the 2. Now, is there anything I can simplify in here? No, there's not. There's nothing I can simplify here. This is all exactly the way it should be. This is my final answer. Y equals 2/3 x plus 2/3. Okay, so now I want you guys to try this problem. I want you guys to try 5x plus 2y equals 10. So right now I want you to pause the video and I want you to solve for y. So pause the video and solve for y. Okay, assuming you have paused the video and have actually tried this out, what is our whole entire goal? Our goal is to get what by itself? Y. Our goal is to get y by itself. So again, I always circle it. I circle my y because that just makes me realize that is ultimately what I want to get by itself. And then I look at it and I see what is happening. Well, I'm multiplying by 2. I'm also adding a positive 5x. So in order to get rid of that 5x, I had to subtract, and I hope you guys realize that. Subtract 5x from both sides. And again, y equals 10 minus 5x is correct. However, it's much better to put the x value in front. And you need to realize that this is negative 5x. So 2y equals negative 5x plus 10 is the better way to write this out. So how do I get y by itself? You had to divide, right? Divide by 2. So each term got divided by 2. And then my final answer on this is y equals negative 5 over 2x plus 5, because I can simplify 10 over 5. Can I simplify negative 5 over 2? I could turn it into a mixed number. However, I really am going to encourage you that whatever is in front of x, you want to just leave it as is, as an improper fraction or a regular fraction. You do not want to turn it into a mixed number. And we'll discuss why later down the road. Okay, so I want you to try out this problem. 3x equals y minus 2. This one actually looks a little bit easier, doesn't it? Go ahead and pause the video and try this one out. Okay, assuming you paused the video and you have worked this one out, what did you come up with? If you came up with y equals 3x plus 2, you're totally correct. Because you had to realize that, hey, I want to get y by itself, so again, I circled it. And then I realized that the 2 is being subtracted. Well, the only way to get rid of subtraction is to add. So I had to add 2 to both sides. Came up with 3x plus 2 equals y. And I just went ahead and flipped it. I went ahead and said y equals 3x plus 2. Are those the exact same thing? Yeah, they are. Nothing changed. I just literally pretty much flipped it. I wrote the y on the left-hand side, 3x plus 2 on the right-hand side. So I moved the y to the left-hand side. Okay, that concludes part 3 of your guys' notes.